This video is for lesson 7-1, parallel lines and angle relationships. The learning goals are to make conjectures about the angles formed by a pair of parallel lines and a transversal line, and then we'll prove theorems about these angles. Matt works for a company called Patios by Madeline. A new customer has asked him to design a patio and walkway. The rows of bricks in the patio will be parallel to the walkway as shown in the diagram. So over here is the walkway, and notice that the bricks are running parallel to that walkway. So far, Matt has used stakes to tie down two parallel strings that he can use to align rows of bricks. He also used paint to mark the underground gas line to the house so that he can avoid accidents during construction. The string lines and the gas line intersect to form 8 angles. So this drawing here is that patio and walkway, but the outline of the bricks is removed so that we can focus on the geometry in the situation. So here we have a string line, and then parallel to it we have another string line, and then right here was that painted marking for the gas line. And that creates 8 angles that are numbered 1, 2, 3, 4, 5, 6, 7, and 8. The next question is use a protractor to measure each of the numbered angles formed by the string lines and the gas line on the previous page. And so I actually measured them already and wrote the measures in purple. 4 of them are 115 degrees and the other 4 of them are 65 degrees. Number 2. The gas line is a transversal of the string lines. Name the angle pairs formed by these lines that match each description. So first we're looking for 4 pairs that are called corresponding angles. So we need to know what corresponding angles are, and that's written over here on the side. Corresponding angles are a pair of non-adjacent angles such that the angles are on the same side of the transversal, and one angle is outside the 2 lines and one angle is between the 2 lines. That's a pretty complicated description of what's a pretty straightforward concept. Corresponding angles look like they're in the same positions on each parallel line. So here we have this line, and then we have this line that's parallel. The transversal is cutting through them, and we have like this top left angle of those 4 angles. Down here we have this top left angle of those 4 angles. Those are corresponding angles. Here's another example. This one right here. This we might describe as being like the bottom right angle of those 4 angles, and its corresponding angle is this one. So it's like they're similar positions located at each of the parallel lines. So hopefully that description's a little clearer than this very wordy, technical sounding definition over here. We were supposed to name them. That's angle 1 and angle 5, 2 and 6, 3 and 7, 4 and 8. Those are the corresponding angles in that drawing. Okay, next, we want to name 2 pairs of same side interior angles. This is actually a little descriptive of what we're looking for. Be on the same side of the transversal and be on the interior of the parallel lines. So going back to our picture, here's the transversal. It was that gas line running straight up and down. Be on the same side of it. So over here on the left side of it, that angle and that angle are on the interior of the parallel lines. Those are same side interior angles. Likewise, over here on the right side of the transversal, these 2 angles are same side interior angles. And so we have angle 4 and 5 and angles 3 and 6. Next, we're looking for 2 pairs of alternate interior angles. So interior, we want to be between the parallel lines, but on alternate sides of the transversal. So going back to the drawing, Interior angles were restricted to these 4 angles. These are the interior angles. Alternate interior angles are this one plus this one. These two are on alternate sides of that transversal. And the other pair is this one and this one. And so we have angle 4 and angle 6, and angle 3 and angle 5. So here's some new vocabulary words that have to do with parallel lines. Corresponding, same side interior, and alternate interior. Number 3, based on your answers to items 1 and 2, make a conjecture about each type of angle formed by parallel lines and a transversal. So first of all, the corresponding angles. Notice that angle 1 is 115 and its corresponding angle, angle 5, is 115. They are congruent. Notice that angle 2, 65, and angle 6, 65, those corresponding angles are congruent. Notice that angle 3, 115, and angle 8, 115, those corresponding angles are congruent. So I think we can say that corresponding angles are congruent. Now next, same side interior angles. Let's go back and look at that drawing. Same side interior angles would be like angle 4 and angle 5, 65 and 115 degrees. Those add up to 180. Those are supplementary. And similarly, angle 3 and angle 6 add up to 180. They're supplementary. So our conclusion about same side interior angles is that they are supplementary. Alternate interior angles. Okay, back to that drawing. Let's find the alternate interior angles. That would be angle 4 with angle 6, 65 degrees and 65 degrees. They are congruent. The other pair of alternate interior angles are the 115, and then over here, this 115. They are congruent. So we can conclude that alternate interior angles are congruent. Okay, number 4, it says draw a transversal to the parallel lines. And then in the next question, we're going to number the angles formed and record the measure of each angle. And so I'm going to pass some random line crossing through both of them. This is called a transversal. And then number the angles. So 1, 2, 3, 4, 5, 6, 7, and 8. Now record the measure of each angle. When I put a protractor on this angle right here turns out to be approximately 45 degrees, as does all angles that have that same acute look to them. Angle 1, when measured on a protractor, is 135 degrees. Again, if that's a straight line, they have to be supplementary, correct? And then all angles that are that same obtuse shape as angle 1 are also going to be 135 degrees. So number the angles and record the measure of each angle. Number 5. Do your answers to item 4 confirm the conjectures you made in item 3 and explain? Yes, they do. For corresponding angles, our measurements show that angle 1 is congruent to angle 5, 135 and 135. Angle 2 is congruent to angle 6, 45 degrees and 45 degrees. 3 is congruent to 7, and angle 4 is congruent to angle 8. Okay, what about the same side interior angles? Our conjecture was that they're supplementary. In this drawing, 4 is 45 degrees, and angle 5 is 135 degrees, and yes, those are supplementary. Also, 3 and 6 are supplementary. And finally, alternate interior angles. Our conjecture was that they are congruent. And in this picture, yes, angle 4 is congruent to angle 6, and angle 5 is congruent to angle 3. Number 6, the corresponding angles postulate involves angles formed by two parallel lines cut by a transversal. Question A, based on our earlier conjecture, Write the corresponding angles postulate in if-then form. I've done that in purple. If parallel lines are crossed by a transversal, then corresponding angles are congruent. Question B, do you need to prove that this postulate is true? And the answer is no, because postulates are assumed to be true. Number 7, the alternate interior angles theorem and the same side interior angles theorem also involve angles formed by parallel lines cut by a transversal. Based on our earlier conjecture, write the alternate interior angles theorem in if-then form. All right, how about like this? If parallel lines are crossed by a transversal, then alternate interior angles are congruent. And the next one, if parallel lines are crossed by a transversal, then same side interior angles are supplementary. So notice that it's the corresponding angles that are congruent, the alternate interior angles that are congruent, but the same side interior angles are supplementary. Here are some check your understanding questions, so I'll pause the video. Number 12, complete the following proof of the same side interior angles theorem. Because this one was a theorem and not a postulate, it can be proved to be true. Our given information is that we have some parallel lines and then this transversal passing through, and we want to prove that angle 4 right here and angle 5 right here are supplementary. These are same side interior angles. We want to actually prove that they're supplementary. So start by writing down the given information. We have parallel lines. We can say that angle 1 is congruent to angle 5 because of the corresponding angles postulate. So I'm looking at the drawing. I'm noticing that number 1 and number 5 are in corresponding positions, so I know that they're congruent because of this postulate. Next step, because they're congruent, we know that their measures are equal. The reason is the definition of congruent angles. Okay, next step, I'm going back to looking at the drawing and trying to pick out things that I see in the drawing. I think that the measure of angle 1 plus the measure of angle 4 is 180 degrees. Here's angle 1. Right next to it is angle 4, and together they're creating that straight line. So I think that that means that their measures add up to 180. My reasoning is the linear pair postulate. I don't think we talked about that one earlier this year, but that's the reason why you know that these two supplementary angles would add to 180. Okay, in the next step, we're going to take this equation that we just created and replace the measure of angle 1 with something that we know is equal to it. And that makes this equation. That's substitution. And final step. Because these two angles add up to 180, we can say that they are supplementary. That's the definition of supplementary angles. So we've created what we were trying to prove up there. Here are a few more check your understanding questions. So in this lesson, we made some conjectures about the angles formed by parallel lines and a transversal line. There were 3 types that we looked at corresponding. Our conjecture was they're congruent. We looked at same side interior, and our conjecture was that they are supplementary. And we looked at alternate interior and found out that they're congruent. We even proved one of those theorems.